Hello everyone, good morning, good afternoon. Welcome to this MicroFocus CORBA webinar. My name is Ed Airy, Product Marketing Director for our CORBA Solutions. Very happy to have you with us here today for the next edition of our Future of CORBA webinar series. Today's discussion is going to be a closer look at CORBA security and SSL. We have quite a few special guests with us here today. You have an opportunity very shortly to meet Mark Tetlow, Senior Systems Engineer within our CORBA business. Also joining Mark is Robert Delaney. Robert is a Senior Software Engineer as well within our CORBA business. Robert will be leading a demonstration for today's session. Also joining us, and welcome back, it's great to have you here, John Draga. John is our Director of Product Development, but also Engineering for our CORBA Solutions. As I mentioned, today's discussion is going to be a closer look at CORBA security. This is part of a much larger discussion that we've had over the last few weeks. A closer look at the future of CORBA technology, what's possible with these solutions, and how to take these applications forward using next generation technology. If you missed some of our former webinars, a closer look at CORBA and containers, as well as platform modernization, you can quickly catch up by taking a look at some of the webinar replays. The links are available for you here, and we'll certainly post the link for today's broadcast on our website shortly following today's event. Now, before I turn things over to my colleague Mark, just a few comments around today's broadcast. Should you have any questions, please feel free to submit your question using the chat function or questions function within the GoToWebinar control panel. I'll do my best to help you if you have an audio or video problem throughout today's broadcast, but please use the same function to submit your questions during today's Q&A panel. This webinar will be recorded, as I mentioned. We'll post it on the microfocus.com website shortly following today's broadcast, and you'll certainly be able to share that and access that following today's event. So with those items out of the way, what I'd like to do now is introduce our first speaker, again, Mr. Mark Tetlow. Mark, over to you.
Okay, thanks, Ed. So I'm Mark Tetlow. I'm going to start off by doing a brief introduction to myself, to Rob. I'm going to cover an overview of the Security Council, and then I'm going to move into more technical details of the Orbix and the VisiBroker security products. So I'm Mark Tetlow. I'm a software engineer working on the VisiBroker CORBA product, and I'm also the security lead for CORBA. I hold the ISC squared CSSLP certification. That's the Certified Secure Software Lifecycle Professional. The intent of the CSSLP is to validate that software professionals have the expertise to incorporate the core security practices into each phase of the software development lifecycle, from software design, implementation and testing through to deployment. I represent the CORBA products on the MicroFocus Security Council. This involves attending council meetings and coordinating between teams, ensuring that relevant information is channeled in both directions. The CORBA team is also involved in developing the SDLC process and improving its maturity. Robert Delaney is involved in the SDLC process for the Orbix products. Robert is a software engineer on the Orbix team, and he'll be demonstrating how to enable security in Orbix 3 and Orbix 6. Security is a broad and complex topic, and we're only going to scratch the surface in this webinar. So it's also worth pointing out that security features that are highlighted in this webinar are only part of the picture. You'll also need to ensure that you lock down the physical environment and that you deploy the security best practices in your organization. That said, it is a very important topic, and that is why MicroFocus created a central security council as part of our commitment to product security. The Security Council is responsible for defining our secure software development lifecycle, preventing potential security vulnerabilities from getting into our products, identifying and responding to component security vulnerabilities that may be in our products, and finally, measuring the effectiveness of the Security Council. Next slide, please, Ed. In order to guarantee the security of our products, we've implemented an SDLC, which is modeled on the Microsoft SDLC. While there are many tools that can be used to scan products and code for potential vulnerabilities, we've chosen some that we believe are the most appropriate given our code base and the nature of our products. In order to help enable tamper detection in release products, we've defined standardized implementations for code and installer signing. In addition to these items, we've created a structured security vulnerability response process. This process defines how security vulnerabilities are handled, mitigated, and how the results are communicated to our customer base. Next slide, please. Currently, the Security Council is focused on consolidating the results from previous projects. This involves homogenizing scanning tools as well as the resulting reports. In addition to this, we're looking at performing supply chain analysis. This involves looking at third-party components in our products and making sure that vulnerabilities, when detected, are mitigated. While the SDLC is an important part of our infrastructure, it's critical that we measure its adoption and effectiveness via a capability maturity model. Next slide, please, Ed. Now let's talk about security and how it relates to CORBA. What does security look like in CORBA? It's useful to break it down into two layers: transport layer security and CORBA layer security. TLS, transport layer security, is an encryption protocol used to protect data in transit. It's the successor to SSL, the secure socket layer, but you'll hear both terms used interchangeably, and SSL is still widely used in the industry. TLS primarily aims to provide confidentiality or privacy, integrity, and authentication. Authentication is the process of validating the identity of a system user. This can be mandatory or optional depending on your security requirements. At the transport layer, the user can be authenticated using public key cryptography. This involves the exchange and verification of X509 digital certificates. Confidentiality or privacy is about protecting the information from disclosure to unauthorized parties. The connection is made private through the use of encryption. During the TLS handshake, public key cryptography is used to define and share the symmetric session key. Once the key has been shared in the handshake, symmetric cryptography is then used to encrypt the data in transit. When we talk about integrity, we mean the protection of information from being modified by unauthorized parties. TLS provide data integrity by using a message authentication code to prevent undetected loss or alteration of the data during transit. CORBA layer security is defined by a set standard specification, and it provides additional authentication and authorization capabilities. At the CORBA security layer, authentication can be performed using usernames and passwords rather than certificates. Authorization is the process of verifying whether or not a user is allowed to perform a requested action in a system. We can do this at varying levels of granularity, allowing flexibility in your administration. Note that authorization always occurs after the user has been authenticated. Next slide, please. Our products include proven industry standard security toolkits. The C++ runtime for VisiBroker and Orbix use the OpenSSL toolkit. The Java runtimes use JSSE for SSL and TLS communication and JCA for cryptographic operations. On installation, the JSSE implementation provided by the Java SDK is used. Any appropriate implementation following the JSSE framework can be plugged in independent of other provider mechanisms. VisiSecure also uses JAS for the authentication and the authorization mechanism. The latest TLS protocol version is TLS 1.2, and that's enabled by default. We support all the TLS versions, and we're monitoring the progress of TLS version 1.3, and we have plans to include it in the product when it becomes available. The reason we support all the protocols rather than just the latest ones is to maintain backward compatibility for older systems which customers may still be using. VisiBroker and Orbix are aligned with the same version of OpenSSL. The version is carefully selected based on advice from the Security Council to be both up-to-date and stable. The Micro Focus Security Council monitors vulnerabilities in OpenSSL and, where necessary, will recommend version updates which will be rolled out to customers in a timely fashion. Additionally, the CORBA products update the version of OpenSSL for each major product release. This allows us to keep up to date with enhancements and bug fixes. Next slide, please. CORBA layer security provides additional authentication, authorization, and identity management capabilities, and is based on a set of standard specifications adopted by the OMG, the Object Management Group. The CORBA SEC specification for security in distributed object systems is a layer above the underlying TLS, and it supports security features that are not available at the transport layer. The CORBA SEC Level 1 standard specifies support for multiple security features such as authentication and confidentiality, but importantly, it also defines support for security unaware applications being configured to use security. This is important, particularly for small applications, because it removes a whole category of potential security coding errors. This is a feature that we're going to demonstrate later. The CSIV2 authentication is a simple client authentication mechanism based on a username and a password. In a system with a large number of clients, it's significantly easier to administer CSIV2 client authentication than it is to administer TLS certificate-based authentication. At this layer, you have the option to use username and password credentials, as well as X509 certificates. Note that CSIV2 authentication over transport cannot provide adequate security on its own. The authentication over transport mechanism relies on the TLS to provide the following additional security features: authentication, privacy, and integrity. The GSSUP standard is used to transmit the username and the password, and the security service is used to verify the credentials. Through the use of the Orbix KDM, the K distribution mechanism, or the VisiBroker Vault, the Orb can distribute passphrases to automatically launch servers. The KDM or the Vault are responsible for managing the secure storage and retrieval of authentication data. They aid both the usability and the security of the product by providing username and password credentials automatically without any user interaction. CORBA layer security offers features to define what operations users are authorized to perform. Authorization is based on the user's identity and access control lists. These use a role database to associate user identity with a role. Access control lists, or ACLs, are used to specify which users or system processes are granted access to objects, as well as what operations are allowed on a given object. ACLs typically allow access to be constrained at varying levels of granularity, such as per process, object, interface, or operation. Orbix 6 introduced the concept of an ACL repository to solve the problem of large, complex deployments and scattered ACL files. Orbix 6 and VisiSecure provide the ability to plug in an authorization service that can map users to roles. Identity assertion occurs when 3 or more servers with secure components are involved in a client request. That's a mid-tier server scenario. At times, it's necessary for a server to act on behalf of its clients. At such times, access control decisions must be based on the original caller's privileges and not on its own privileges. The typical CSIV2 identity assertion / delegation scenario involves a client, an intermediate server, and a target server. Once the client has authenticated itself to the intermediate server can impersonate the client by including an identity token in the request that it sends to the target server. The intermediate server thus acts as a proxy or a delegate server. With impersonation, the mid-tier server can perform any task on behalf of the client, but with delegation, the client explicitly delegates certain privileges to the server. In this case, the server is allowed to perform only certain actions dictated by the client. Next slide, please. Okay, so we're now going to demonstrate how easy it is to enable transport layer security in our products. Next slide, please, Ed. We're going to use the latest product releases for this demo: VisiBroker 8.5 SP5, Orbix 3.3.14, and Orbix 6.3.10, which are scheduled to be made generally available at the end of June. Please note that these demos use certificates and certificate authorities that are shipped as part of the product samples and therefore should not be used in a production environment. I'm going to start off the demonstration with VisiBroker, and then Robert Delaney is going to run through Orbix 6 and then Orbix 3. So Ed, if you could share my screen, please. Okay, can you see the property files that I'm now sharing?
Looks good, Mark.
Okay, great. So I'll get started. So I'm going to start off by demonstrating transport layer security in a non-security aware application. So for this demonstration, I'm going to use the VisiBroker Bank SSL security example. This example makes use of the basic bank agent that is not security aware in any way. It then enables security by simply using a small number of VisiBroker properties on the command line. So just to reiterate, the client and the server application source code does not call any security related APIs. So what you can see on my screen here is on the left, you can see the server property file that we're going to load in when we run the server to enable security. And on the right hand side, you can see the client properties. Now I've just rearranged these properties just to show the alignment so that you can see the difference between the server and the client. The top two properties on the server are the main ones that will switch on security. This first property, server.transport equals secure only, will force the server to start up in a secure mode, and it will instruct the server to reject non-secure connections from clients. This next property, require authentication equals false. This is switching off the topic that I talked about earlier, GSSUP, the client usernames and passwords. This just switches off that mechanism. So we're not going to be using that today. We're going to be using transport layer authentication. The next property, pure authentication mode, require and trust, is set on both the client and the server. This instructs from the client side, it instructs the server, from the client side, it instructs the server it must provide a certificate, and that certificate must be trusted. And that's the same on the client side. So the server instructs the client it must provide a certificate, and that must be trusted. The trust point itself is set up with this property, trust points repository. In this scenario, it's a directory, and it's the local directory trust points. Any certificates that are loaded into that directory are deemed trusted certificates, and you will generally put CAs or intermediate CAs into this directory. The next, wallet.type identities, is instructing the server and the client which directory to load its certificates and private keys from. And the wallet.identity says that for the server, it's going to take the identity of Franz. So there's a Franz certificate in the identities directory, and there's a Franz private key in there. And you can see the same on the client side. The only difference is that we're taking the Charles identity. Okay. I'm going to start just to verify that we've got the OS agent running. So in this example, what I've done so far is I've compiled the basic bank example. I've copied the server and the client into this bank SSL directory. So that has taken a non-security aware client and server, and I've now dropped it into the bank SSL directory, and I'm going to run those client and server applications. I've already started the OS agent, so the next thing I'm going to do is I'm going to start up a server, a non-security aware server, just to show what you're going to be expected to see on the screen. I'm now going to start a non-security aware client, and we'll be able to see that it will be able to connect to the server. And this is the type of output we're going to expect to see on the client. It's created the JackB Quick account, and it's obtained the balance from the server, and you can see here that communication. I'm now going to stop that server. I'm now going to take that server and I'm going to enable security. And what you can see here on the command line is I've started the server as before, but the first argument I pass to the server, which ultimately gets passed to the orb, is the orb prop storage equals cpp underscore server.properties. And that's this property file you can see in the background I showed you earlier. The next important argument is the vbroker.orb.dynamic_libs. This instructs the server to dynamically load the VisiBroker security service library. I'm going to run that now. Okay. Now you can immediately see some logging here, and that's because we've got login switched on in the property behind. So the server started up. I'm now going to start the client. The first thing I'm going to do is show you that server is now enabled secure and a secure connection only. So if I run a client that's not got security enabled, we will get no permission back. Interestingly, if we look at the log here, you can see that it says that the POA requires secure only, throwing no permissions. Now what we're going to do is we're going to take that client and we're going to enable security in the client, just like we did in the server. It's actually the same method. Orb prop storage equals cpp, the client property file, and we're going to dynamically load the library just like we did on the server. I'm now going to run that. And for some reason that seems to have blocked, just like you'd expect with when you're running a demo.
Mark, you've got some text selected in the other console. That's why the server is blocked.
Is that what's happened? Okay.
Yeah.
So there we go. There we go. Thanks, Matteo. Much appreciated. So here what we can see on the server, if I just scroll up, the first thing we see is the peer trusted by the following trust points. So I talked about setting up the trust point directory earlier. So this has obtained the Alice certificate, which I happen to know is the root certificate, the root CA on the client side. I scroll up a bit further. We now move into the client certificate chain. So here we have Charles, which is what we configured the client to have the identity of Charles. This was issued by Bob. We'll move up in the chain. We'll see Bob. This was issued by Alice, which we saw earlier was in the trust point directory. And we move up further, and now we find the root CA Alice. Scroll up a little bit further, and we can see that the negotiated cipher on this connection was TLS protocol, ECDHE key exchange, RSA authentication with AES blockchain encryption with a SHA-384 authentication, message authentication code. If we scroll up a little bit further, here you can see the cipher lists that are available on this connection. Okay, so that shows how to enable security in the transport layer on VisiBroker. I'm now going to hand over to Robert, who's going to demonstrate Orbix 3 and Orbix 6. So Ed, if you could just share the screen with Robert, please.
Thanks, Ed. Can you see my screen okay?
Yes, looks good.
Okay, so this first demonstration will show how to deploy a secure domain in Orbix 6. At this point, I've downloaded the product here, and I've also installed the product. You can see my bin and lib directories where I've installed. I also need to set a couple of environment variables. One is the license file. This is our enterprise license file you get when you purchase a product or you download a trial of the product. And also the IT product dir, which is where I've installed my product. One more thing to set is just your Java home, the way you would normally set it. This just allows us to run the IT configure GUI, which I'm about to do now. IT configure is the GUI where we create all our domains, and it's inside of which these domains that we run our servers. So when we start up IT configure, we see we're prompted straight away to create a new domain. The first step, we just need to name the domain. So I'll just put secure in the title for this demonstration. Usually I choose to select the services. We could select all our services, but that would obviously take more time and we'd spend time configuring them. The next portion is a storage location. So when we create a domain, we create configuration files and start scripts for the services, and these go into the etc directory. And we also have a var directory where our logs and databases go. So I'll just go on to the next screen. Here I usually select the button here. This just creates a start script with the services that we choose later on. It's just for ease of use. And if our machine is being used for multiple domains or other processes, we may want to change our base port just to avoid conflicts with other running processes. So next is our security panel. You can see in the upper half of the panel, we have the transports section. This ties in with what Mark spoke about earlier with security being divided into two layers, the transport or underlying layer, which by default we have set to non-secure. We can also set it to semi-secure, which allows both secure and insecure communications, but we'll choose fully secure. Now, when I choose fully secure and you look to the lower half of the screen, you can see our security service is now available for selection. This is our CORBA layer security in Orbix 6, and it allows us to do authorization and the 3-tier examples which Mark spoke of, where you have a client connect to an intermediate server, and then that server forwards on requests to the target server. So I'll also enable him and go next. Fault tolerance. This is another feature we have in the enterprise edition of Orbix. It allows you to make replicas of certain services for backup purposes and load balancing purposes, but we're not going to demo that today, so we'll just go to the next screen. This is where we choose our services. Now we'll make this as simple as possible, and we'll just clear all our services and just choose a locator and a node daemon in addition to our Iona security service, which we selected earlier. This next screen is just a recap screen where you can check what you've already selected, and if everything is in order, we can go ahead with the deployment. So this might just take 30 seconds or so. In the meantime, I'll use this other window. So we spoke earlier and we had etc directory where our configuration files go, and we had a var directory where our databases and log files go. So it looks like we've completed the configure there. So we'll just have a quick look into these directories. Under etc, you can see a bin directory. If we look in the bin, we can see the start script we spoke about. We can see this is batch file is just an environment script. So it's, sorry, I'll just cd in here and run that environment script. So we're set into the correct environment for this domain. And that's the start script here is used to start and stop our services. I'm just going to go into the domains directory now, and we can see our configuration file, which was created by this deployment. If we just examine this, we can see all the configuration variables that we've set. I'm just going to have a look at our ciphers, seeing as we're in a secure domain, and we can see we have a list of 4 ciphers there. So just to show that this is what we actually did use, I'll go back to our var directory and look in our domain into our logs. And if we look at our locator log, we should also see the same ciphers. So if we come down to ciphers here, we can see the cipher list, the same 4 ciphers we saw in the configuration file. Now, perhaps a Security Council or OpenSSL might advise us against using a certain cipher, and you might want to remove that from your list, so you wouldn't accidentally use it. So we'll just do that quickly here in our configuration file. I'll save that file. In IT Configure, actually, we can go back in and we can start our services using this play button, or we could use the script we looked at earlier, but this should be fine. And when we look at our log file, it should have been updated. So I'll just reload that log file in. And if we come to the bottom and then just look back up for ciphers, yes, we can see that our ciphers have changed, and we're definitely going to use this triple des cipher, which we picked. That concludes the Orbix 6 demonstration. So I'll just stop these services and tidy things up for Orbix 6, and then I'll start the Orbix 3 demonstration. Just a couple of windows more to close. So the layout of Orbix 3 is slightly different. What we have is a non-secure kit, which is the base kit most customers will install. And then we have an SSL kit, which is an add-on kit, and which we install on top of the non-secure installation. So that's free of charge, and the licensing is exactly the same as for the non-secure kit. So at this point in this demo, I've already installed the non-secure Orbix 3 kit. And what I'm going to do now is install the secure kit on top of that. So it should be very easy. It should come up, and we'll just be prompted for some information about our existing kit that we wish to install on top of. So we choose the directory where we've installed. I can see here. So we can just go to next, accept the licensing. So this license key we need to fill in. As I said before, security in Orbix 3 is completely free. So the license key you use will be exactly the same as the one you use to install your non-secure kit. So I just have this from earlier. I'll just copy and paste this in. And then finally, we just need to choose our Java. Okay, so this should install for us now. So while we have installed the underlying libraries we need to run in a secure environment, we need to configure that we wish to use full security. So if we go into our configuration file, we should see that we have an additional file now. You can see it's just been added here, this Orbix SSL config file. So I'll just open that up. Okay, so our installation has completed. We don't need to restart our computer. And we're done. So getting back to where I was a second ago, the Orbix SSL configuration file, there's just a couple of changes we need in here to enable security. Actually, just before I do that, I'll start up I'll run our setems file. This is just environment script which sets our variables. I can show it to you there now. It's just a few things like Java home, the Orbix root, config paths, that sort of thing. So if I start up the Orbix daemon now, this is the equivalent of the locator and node daemon in Orbix 6. Sorry, I should have covered some around setems. And we can start Orbix daemon now. And the first thing we see is the configuration, and we see TCP in the string here. So this is just a insecure protocol. So as I said, while we've installed the secure package, we have not configured it yet. So I'm just going to close this window, go into our configuration directory again, and open up our secure config file. So we only need to change a couple of things in here. The first one is that we disable SSL by default. So we need to change this true to be a false. The next thing we will change is the KDM. Mark spoke about this key distribution mechanism, which is used. It's basically a database that is used to store servers and the passwords or passphrases used to unlock the certificates associated with those servers. So we want to enable the KDM, so we will set this to true. And the last thing we will do, our little demonstration will involve the naming service. So I'm just looking at the configuration for our naming service. We can see it here that its policy is insecure, so we will change that to secure now. Okay, so if we start up our Orbix daemon now, we will hopefully see it is in secure mode. Yes, you can see the string there for SSL TCP to tell us we're in secure environment. I will now start the KDM. Don't worry if you see this warning message. This is because it's the first time we've started the KDM. So there's no database containing servers and passwords. We'll populate that now in a second. Yeah, the next time, if you're using the KDM, then the next time you start it up, you shouldn't see this warning message. So I'm now going to use a Orbix 3 specific command. This command is putIt. It's used to add servers to our Orbix daemon. So putIt, as I say, this registers the server with the Orbix daemon. So the format is like putIt NS for our naming service, and then we just do a couple of dashes followed by our argument list. This will be the location of our naming service. So it's in our installation bin, and then ns.bat, and finally we pass the -secure flag. So hopefully we should see some movement in the Orbix daemon up here that we've registered. Yeah, we can see a connection there. So one of the things you can do with the naming service is to list the contents of the naming service. And we're going to try and do that now, but we'll see something interesting happen when we try this. So we're contacting the Orbix daemon and trying to run the naming service to list its contents, but we haven't supplied the correct password. So the Orbix daemon has prompted us back to enter this password. Now the password I know is a demo password, which I could enter here, but we're going to show how to use the KDM here. So we just have another put command to register with the KDM. This is put KDM, NS for the name of our server, and demo password is our passphrase. So we saw some traffic here in the KDM window. So hopefully now when I run my LSNS, we should be able to list the naming service. So we see here in the Orbix daemon, the command came through, it's NS and an attempt to list what's in the naming service. We talked to the KDM to get the password. This time we were successful. So we started up our naming service, and we can see back in our original window that the contents of our NS is here. Obviously we've just installed, so there's nothing really interesting in there for the minute, but we've demonstrated that we can contact the Orbix daemon securely and also the naming service securely. That concludes the Orbix demonstration, so I'll hand back to Ed now.
Okay, shall I carry on now, Ed?
Yes, please.
So just a quick summary, really. So we've demonstrated how to switch on transport layer security in VisiBroker, and Robert's done a very good demonstration of enabling security in the Orbix 3 and the Orbix 6 products. Now this is due to time constraints. There's many other features that we've not had a chance to demonstrate, but that's a very quick overview. So could you just change the slide, please? Oh no, sorry, that's my mistake, you already have. So if you want to get security in these products, for VisiBroker, you need to purchase the VisiSecure component license And for Orbix 6, the transport layer security features are included as in the standard edition. You might want to upgrade to the enterprise license to enable all the additional enterprise features that we talked about in this presentation, including the advanced CORBA layer security features. For Orbix 3, you download and install the Orbix SSL add-on for Orbix 3 at no additional cost. And that concludes the technical presentation from myself and Robert. I'm just going to hand over now to John Drager.
Thanks, Mark. That was great, guys. My name is John Draga. I'm the development director for CORBA products and also the product manager for CORBA. And I just want to talk a little bit about Micro Focus's commitment to CORBA products. We're absolutely committed that the CORBA assets that you developed in previous years will continue to run on today's modern platforms and into the future. We've got a lot of exciting things done. I urge you to go back and look at, if you didn't make the Cloud and Docker webinar, go back and take a look at that. We're talking about how we're leveraging some products that we have in the CORBA suite to run in containers, on Cloud and Docker, whether it's Azure or AWS, we've got you covered. And we've got some really exciting stuff coming up in the seminar in September, where we start talking about how we can leverage some new technology to allow you to access your CORBA assets using REST. That means for you can still have your CORBA assets running, but maybe you don't need to have CORBA expertise in order to access those things. So stay tuned to that. And I want to thank you guys for showing up for today's webinar. And stay tuned. We got a lot of great stuff coming out this year.
John, thank you very much. Mark and Robert, thank you as well for the demonstrations. Before we move to the Q&A panel, just a few comments here regarding next steps. If you're interested, of course, in taking a closer look at some of the CORBA technology that was discussed and demonstrated today, the simplest way to do that is to reach out to your account manager. They can help you get started, get you connected with the demonstration, or even connected with one of our technical experts to discuss some of the scenarios or specifics around your environment to help you get started with security for CORBA solutions. You can also download your free trial today on our website at microfocus.com/products/CORBA. Again, you can select the product that would be appropriate for you, VisiBroker or some of the Orbix technology we've shown here today, and you can get started using that technology. So let's move into the Q&A panel discussion. This is your opportunity to pose your questions to our panel of experts. And again, the best way to do that is to submit your question through the Q&A chat function within the GoToWebinar control panel. I'll give you a few moments to do that here, and I'll compile some of the questions that have already been submitted. So I'll be back just shortly. All right, it looks like we have our first question here. It relates to the demonstration. The question is, you mentioned in the demo that we shouldn't use sample certificates in our production environment. Given that being the case, how do we go about obtaining our own production certificates?
I can take that one out if you like. Basically, you would have two choices in this. The first one would be you could make them yourself. The way we would have done it to create those certificates that are shipped in the product. So we would use the OpenSSL command line utility for that. And there's actually information in our docs to walk you through that process. The second option would be to get a third party, like a commercial certificate authority to do this for you. That would I suppose would cost money, but I would say if your application is in-house, then self-signed or self-created certificates are probably okay. But if external customers were using your application, then you'd probably want to get a third-party commercial certificate authority to do it for you.
Rob, thank you. Okay, our second question. So how quickly does Micro Focus patch a discovered vulnerability in OpenSSL? Mark, maybe that's one for you.
Sure. Yeah, I can talk about that. It's probably best to start by talking about the process we go through, really. So when vulnerabilities are reported, we have teams within the Security Council that monitor for vulnerabilities in various third-party components. OpenSSL being the one that we're generally talking about in this presentation, but there are others. So it's very much driven through the Security Council. They will then analyze that vulnerability or the potential vulnerability, and they will then send requests off to the various teams that are listed as using that component, and then it's down to the individual. So in this case, it would be down to myself and Robert to then coordinate the analysis of that particular vulnerability. So there isn't a straight, quick answer to that, but it goes through that process. We would then, once we analyze it in our teams, only then would we know whether our products are actually vulnerable to that vulnerability, or susceptible to that vulnerability. So that's the point we can then determine if we need to take any action to this, because not every vulnerability would affect each individual product. So if it's deemed that we are vulnerable, then we can plan that work as a high priority. It might be that the simple solution is just to bump the version of OpenSSL, in which case that would then, we would get those versions of OpenSSL built, put through test, and we could then provide hot fixes for each different product. Apologies if that isn't a succinct enough answer.
No, that's great, Mark. That's great. Thank you. Okay, another question here related to Cipher suites. Let's see, again, going back to the demonstration, you highlighted the Cipher suites. Can you explain a little bit more about what these are?
Okay, do you want me to take that one as well?
Please, go ahead.
So it might be worth if I share my screen. Would you mind sharing my screen, please, Ed? Okay, share my screen. So what I will do is I will rerun the example and bring up the Cipher suite. So bear with me a second. Okay, here we go. So if we scroll back to the top, so we find the Cipher suite that was negotiated. Here we go. So here's an example of the Cipher suite. So you can break these down into the different individual methods known as algorithms. So the first one here that I've highlighted is the protocol, SSL or TLS. So this is obviously TLS. The next method here is, which in this case is ECDHE. That's the key exchange algorithm. So that is the algorithm that's used for this connection to exchange the keys in a public key scenario. So what you do is, this is the algorithm that's used to exchange a symmetric key, which will then be used for the encryption of the data in transit. So the symmetric, the whole point is that you use public key to exchange the keys, and then you switch over to symmetric key because it's quicker. The next one here, RSA. Now that is the authentication algorithm. So that is used for the client authenticating the server, and if configured, the server authenticating the client. And then we switch over past the with, we go to this is the algorithm that's used for the actual encryption of the data in transit. So we've got AES with 256-bit key. Now this here is the mode. So the last part here is the message authentication code, the MAC. So in this case, it's SHA-384, 384 being how many bits are used. So you could think of the Cipher suite. you can actually configure it in all these products, or you can just rely on, in this case, the example I've used here, that this is just negotiated the most secure cipher suite that's supported on both the client and the server. I don't know if that answers the question, if that's down to enough detail.
That's great, Mark. Thank you. All right, here we have time for a few more questions. There's a question here related to open source and JA-ORB. Any support for that capability?
I'm not sure who the best person to take this. Whether John wants to talk about whether we've got a roadmap. The JA-ORB, was that?
Yes, support for open source, specifically with JA-ORB.
Well, I mean, we have our own open source products. I'm not familiar with JA-ORB. So our open source products, our Open Fusion line is DAO and Jack-ORB. We take these off of the historic sites that are maintaining those open source versions. You get a little more detail maybe about what they're talking about, or can you help me out, Mark, on what they're talking about? JA-ORB?
I must admit I'm not familiar with that either, John.
Maybe that's Jack-ORB.
Yeah, perhaps.
We do support Jack-ORB, and it does have security. So I mean, maybe I can talk about, maybe they can confirm in the panel that's what they're talking about is Jack-ORB. So we have full security for DAO and Jack-ORB as well. This presentation, we're handling the Premier orbs. There's recently been some changes on our website, so the landing page for the CORBA products now talks about, we've done some differentiation. So we talk about Premier orbs, which are Orbix and VisiBroker, and we talk about our source available orb, which is Orbicus, and we talk about our open source orbs, which are DAO and Jack-ORB, which were they were products that we purchased from PrismTech under the Open Fusion product line. So those products as well support security, if that's what the question was.
That's perfect, John. Thank you. This might be another question for you here, just related to perhaps some of the conversations you've had with other customers. It looks like this customer is very familiar with some of the integration work we've done within our COBOL business, particularly with REST and APIs. So they're curious to know our view in terms of the demand for COBOL integration, particularly with mainframe applications. Is that still something we see?
We do have some pretty large customers that still are running CORBA on mainframes. There's an obvious one which I won't name, and we have support for that in Orbix, as well as some support in VisiBroker as well. So one of the things I maybe didn't mention so much in the commitment is that we have not terminated support really for any of the older versions on the VisiBroker line. So we still are actively assisting customers regardless of what version you're running or what platform you're running. They're still all viable.
All right, thank you, John. And yes, the question did refer to Jack-ORB, support for Java-based.
Oh, there you go. See, I'm a mind reader too.
Very good. Very good. All right.
Yeah,
Well,
we just didn't demo it today because of time constraints more than anything else. But we do have security support for DAO and Jack-ORB as well.
All right, thank you, John. Well, it looks like that was the last question, and we're just about at the top of the hour. So if there are other questions, please feel free to submit them through the Q&A chat function and go to webinar. We'll give you another moment or so. All right, well, that looks like it might be it for questions today. Mark, Robert, John, thank you very much for the content and discussion and demonstrations here today. Thank you as well, folks, for joining us on today's broadcast. This webinar will be posted on the microfocus.com website. And certainly don't forget that there is another edition of the Future of CORBA applications that will be coming to you in September, where we focus around REST and JSON integration with our CORBA technology. So watch your inbox and certainly watch the website for more information around that upcoming webinar. If you have any questions, again, in terms of next steps, please reach out to your account manager. They can help you get started and certainly help you address some of the questions you may have around CORBA security and even help you get started with a product trial. Thanks again for spending a part of your day with us, and have a great day.
Thank you.
Thank you, guys. Thank you.
Thanks.